Well, hi everyone. Thanks for joining us today. My name is Juliette and I'll be your host. Before we get started, if you have any questions during the presentation, please type them in the chat window and we'll have an open Q&A session at the end. Okay, let's begin with an introduction of today's speakers. Jeff, would you like to start?
Yes, of course. So my name is Jean-François Piot. So I'm a VP Product Marketing at JSX. Like 10 years I'm here now. I'm very happy to present that webinar with you. Pavan?
Hi, myself Pavan. I'm working for GSX as Technical Pre-Sales Engineer. I'm certified Microsoft O365.
Okay, great. So let's go through the agenda. We have a lot to talk about today. So today we'll focus first on how to detect and analyze SharePoint Online performance issues. And then we will see how to improve the end user experience. And finally, we will show you in real life with real statistics the impact of network configuration, boot to the cloud on your end-to-day service delivery. So let's go on the first topic, the performance of SharePoint Online. So besides cost, availability, and data security, we hear a last very important concern from our customer, and that is, of course, the internet reliability and the end-user performance. SharePoint has the reputation sometimes to be a bit slow, even on premises. So the question is, what will it be when it will be fully available through the cloud? And if you Google SharePoint Online performance, you will see that our customers are not alone to wonder about how to ensure a decent end-user experience. You will see as well that Microsoft support, Microsoft TechNet, and other community sites are full of questions about it. So we will try to answer some of these questions today. As you may have experienced, it is sometimes complicated when using SharePoint Online to really understand where the latency is coming from and who is responsible for that. Usually, sometimes we have seen that in large organizations, that there's a kind of blame game where you don't understand and you blame another team. So sometimes it's the network, or it's the hybrid identities, or it's the security, or this kind of thing. So really what we want to do now is to try to get back visibility on who is responsible for what. So let's go on our first real topic, meaning how to detect performance issues. So if we can go on the next slide. So the first thing that seems obvious is the relativity of performance. Not every location nor every user has the same definition of performance. And what is acceptable in one location is maybe not in a second one. Moreover, even in the same location, users have different perception of performance too. And finally, Microsoft has another perception of performance, and you can see that as well in different forums or answer to questions. So the first requirement is to being able to understand the end user experience, to measure it, and to be able to establish a baseline, location per location, based on what is good for each of them. So a baseline is established using historical statistics, of course, we will see later on how to do, but it's also here to predict performance. For that, you need to constantly measure on very short interval over days, weeks, and sometimes months, the end user experience. The purpose is to identify every recurring peak of charge and performance issue that can be associated. Sometimes it's every Monday, sometimes it's the first week of the month, sometimes it's the last month of the year. It really depends. So you need to have this measure to know what is the end user experience, to know when you have peak of charge, and to be able to take action on that. So this baseline by location really will be extremely useful when it comes to understand your end user performance issues, and when it comes to troubleshooting, that is what we will see and do right after. At the same time, collecting network statistics that you can correlate with the end user experience is also something that will help you greatly. We've seen that at many customers. Again, because most of the time, when you have a problem of performance with SharePoint Online, nine times out of 10, it is your problem. It's not, I mean, sometimes there's a Microsoft problem, and we will see that depending on what server you use or this kind of thing. But a lot of time it's your problem, so it's very important to collect these network statistics at the same time that you collect the end user experience in order to be able to correlate what's going on. So now that we've seen how collect end user experience, network statistics, why it's very important to do that. Let's go to the next slide to analyze a bit the issues. So for that, I mean, if you go again on the forum, you can see most of the time two big tools, the F12, the developer tool, and the SharePoint Diagnostic tool. And Pavan will explain us how to use them, why they are important, what kind of statistics you can find there, and how you can troubleshoot your issue with that. Pavan?
Yeah, sure, Jeff. Today we focus on two tools which help us to troubleshoot page performance for SharePoint Online. One is F12 and another one is SharePoint Diagnostic tools for online. Let's discuss on F12 first. So SharePoint Online, as we know, like it's a block box for users and customer, and there are a lot. We need to perform basic troubleshooting analysis for slow pages. Today I'm going to show you how we can enable F12 through Explorer and the parameters we need to look for. Okay, let me go to my server. Yes. Okay, so I have opened my Internet Explorer. Okay, let's navigate to, I navigated to page called recyclebin.aspx. So today we are going to analyze the performance for this page. Let's go to the gear icon on right corner of computer. Here you can find F12 developer tools which you need to enable. Okay, once press F2 to load the page on the browser. Okay, let's go ahead and click on F12. Yep. So as soon as you press on F2 and load the page on browser, so you will see the new page opened with a lot of statistics. So here we can see a lot of pages which trying to navigate. Okay, on a network page, you can able to see start profiling session, which will allow us to start the traces, and there is another button to stop profiling session. Okay, so I'm going to start the session, and let's see, and I will let you know like when to stop as well. Like so there is a stop button. I'm going to click on stop button. Okay, here you can see there are a lot of pages. So first we need to identify what is our page which we would like to look for. So here I'm looking for a recycle bin ASPX page. So we can confirm through request URL here, and there is three important parameters which we would like to see here. One is SPIAS latency, SP request duration, and SP health score. So what is it exactly? So SPIAS latency, in my case it is showing as 1 millisecond. So this is actually amount of time that the request spent queued and waiting to be processed by your IIS server. Ideally it should be 0. So as I said, like my case it is showing as 1 millisecond. Next, SP request duration. So this is amount of time that took to process the request on the server. So in my case it is showing as 990 milliseconds. And SP health score. So this is the value from 0 to 10 that indicates how heavily loaded the SharePoint server. So at the time when the page was served. So it should be 0, yes, is showing. Like if it is a 10 means its page is heavily loaded. Okay, there is, so all these three important parameters. Next, we'll see there is a 3.3 seconds parameter which is showing, which we call it as a time spent or total trip time. So we can see like it took almost 3.3 seconds to load the page, and SPIS latency is 1 and SP request duration is 990 milliseconds. So there is a small formula which we can say like a total trip time minus SP request duration plus SPIS latency. So if you consider this, so 1 millisecond and 990 milliseconds, it's going to be 991 milliseconds. So out of that 3.3 seconds which it took to load the page. So what about another approximately 2.1 seconds? So that is where we consider as a time lost. So we need to see like where the time lost is happening. This is where we need to troubleshoot and fix the issue. So basically like Microsoft will say like if you have high time lost, then there is a slowness between your computer and SharePoint Online. So it could be a routing, proxy, or internal network. If there is a high SPIS latency, then it represents an issue on the server side. Also suggests requests are backing up on server. So if there is a high SP request duration, what we see here, it means page taking long time to process on server. So it doesn't mean like it's not only issue on SP online. Okay, there are a lot of customizations, navigation style, and web parts in your page also cause the performance issue and take a lot of time to load the page. So we can also discuss about these suggestions in the next slide. Yeah, which can conclude the issue. Yes, Jeff. So this is the page which I am saying you like what is the total trip time and how we can calculate the time lost and where the time lost is happening. Yeah. So as you know very well, each and every tool has a limitation. We recently observed most of the pages in SharePoint not showing SP request duration and SPIS latency. So Microsoft is aware and has released another solution called Page Diagnostic for SharePoint Online. Okay, we are going to show you now how we can enable this diagnostic tool and what parameters we can get it from the solution. Okay, so basically like we can go ahead and download this tool using Google Chrome. So in my case, I already downloaded. Let me show you the tool. Yep. As soon as you open the browser, you can see the extension log. So once you download the tool, you can able to see there is extension log in your web page, which you need to click to load the solution. So we always recommend to get a better results, please delete your browser cache and open the page again. Okay, like a F12 developer tool, this tool also will show you the page load time, correlation ID, SPIS latency, SP request duration values. Okay, let me go ahead and load the tool. So here my page is like a webinar site pages home page where I'm going to start the page. So it's trying to load. As soon as you load the page, you see there is a correlation ID. So it's really required when you are working with Microsoft support. And also it shows a page load time, how much time it takes to load the page. And also if you observe, there is two important tabs in this SharePoint diagnostic tool. One is diagnostic information and network stream. So diagnostic information will tell you whether how you are running the solution and what is the best practices you can take and where it is failing. And also if you go to the network trace, it will tell you like how much time it takes to process each tab, whether which page is taking much time. Okay, so let me go ahead and load the tool. So I'm just going to run the tool again for you to show you the network trace. Yes. So let me go ahead and stop it as it is showing the information. Yep. You see here, it is going to show you exactly how much time it takes to load a page and each, it traverses each query one by one and show you how much time it takes. So there is a color coded what you see like red and green. So basically the code based on the impact on overall page performance. So if it is green, it will be less than 500 milliseconds, yellow means 500 to 100 milliseconds, and red represents more than 1000 milliseconds. Yes, as you say, like there is a limitation in each and every tool. We see the page diagnostic tool only useful to analyze your classic publishing pages and pages on classic theme sites. Okay, and also we observed this tool will not run against any document libraries or system pages. So what we can say is this page is especially designed to review SharePoint site pages. Yes, Jeff. Yeah.
Okay. Well, thank you, Pavan. I guess it was some good tips to analyze the performance issue when it deals with a web page loading time. So now, do you have some more tips to improve this load time when you have a spot problem?
Yes, Jeff. There are several tips to be considered. Of course, if possible to limit the customization of your SharePoint online web page, customization can dramatically increase the load time. Even Microsoft recommends comparing the load page of your SharePoint page to OneDrive home page. That usually give us a good understanding of the performance you can achieve when the customization is off. Also, we see like there is a CDNs, content search web part, and navigation style, how you set it up in your SharePoint online pages. So what is CDN? CDN is Content Delivery Network, a worldwide network of servers that host same files, internet URLs, okay, that are interpreted by the client machine so that the server that is closest to the user serves the file. So doing this significantly reduces delays caused by the network round trips. So it also improves the performance. As I said, like content search web part, there are two type of web part. What we see like content search web part and content query web part. So we recommend to use the content search web part as a replacement for query web part, as content web part generates a high SQL load as it traverses all times in the query for each and every page and impacts overall page performance. And also like the navigation style, how you set it up in your page, where our settings, check for style what it was designed for SP on-premise server. So please change it to manage navigation or custom provider. And also like it depends on your size requirements, on your technical capability. Yeah, that's the tips we can consider from our end. Yeah.
Okay. Well, thank you once again. So let's go through another set of tips now that can have a huge impact on SharePoint and user performance, and that we have seen working at a lot of customers. So as you may have read on several blogs and Microsoft TechNet, the route to the cloud has a significant impact on cloud service delivery performance. The route to the cloud is, of course, made of your infrastructure, your network, as well, of course, as the one of your ISP. So several points have to be identified that you should really consider. The distance to the Microsoft data center, the use of a proxy, the DNS configuration, and the bandwidth requirements. And we will see a little bit later with real statistics how all of that really impacts the end user experience. So the general advice is to decrease as much as you can the physical distance between your user and the SharePoint server in the Microsoft Cloud. We've seen plenty of configuration where users in Asia, for example, are accessing a tenant in Europe or in USA. And every time, the performance is lower than a European user that would access a European tenant, or an Asian user that would access an Asian tenant. So again, in 5 minutes, we will show you that with real statistics. The second point is the use of a proxy. And we know that many of you force your user to go through their proxy before accessing Microsoft services. Usually you do that for security reasons, but you should really consider the pro and cons. The use of a proxy, and again we'll see that with real statistics, significantly decrease the end user experience. DNS configuration is also something that can impact the performance. And finally, of course, the bandwidth. I mean, that's pretty obvious, but again, we'll see how dramatic it can be. So we'll show you that all of that in Power BI dashboard in 5 minutes. Let's take a look now at the test protocol. How did we organize ourselves to show you the results that we will show you in 5 minutes? Pavan, can you explain it a little bit?
Sure, Jeff. Okay. So as you may know, we provide robot users that use Office 365 as a user, that will log in, upload and download document on SharePoint and OneDrive. To understand the impact of route to the cloud and your network configuration, we set up multiple robot users performing the same scenarios with various route and network configurations. So what is robot user? So robot users are Windows services that you can install in any location you want, and that will use Office 365 exactly as a user. It will also collect critical network statistics to help you to troubleshoot any performance issues. So let me explain like what is the configurations we have, and we are going to show you as well. So we have one robot running from Nice location, France, with a low bandwidth accessing US tenant. Another robot running from Nice location with a proxy to access Microsoft Cloud services in the US. We have another robot running from Nice with a incorrect DNS configuration accessing the same US tenant, and another ideal robot running from Nice with normal condition accessing US tenant. Also, like we have a file robot from Nice location accessing a normal condition with a European tenant. Yes, Jeff.
Okay, so thank you. Yeah. So let's see the results. Let's go on Power BI.
Sure.
So basically, so all these robots, they collect, so they perform their tests, they collect the network statistics, and all these statistics are collected to a SQL database. And then from this SQL database, we are doing Power BI dashboard in order to show and to see the service quality that is delivered to all these locations thanks to this robot user statistics. So that's a dashboard. That's one example. But let's go live. Let's go on Power BI and let's take a look at the different results. Okay, so we are in Power BI now. So again, all these statistics are coming from different robot users that are performing their job and collect statistics. So I will start by explaining what we can see here, like what means every graph, and then Pavan will go through each robot user and show you individually the difference of results. So this dashboard is one of many we created. Again, it depends on the customer needs, it depends on what they want. The purpose is to provide a comprehensive view on the service delivered to multiple locations. So at the top of the screen, you can see three gauges. Okay, the first one on the left is for the percentage of availability of the service. It counts over the period of time, the percentage of time the robot could actually do the action. So it's really up or down. Here we have overall 98.87%. That's not that bad. The second one shows the service performance. So it counts the percentage of time the actions were made within reasonable performance. Here we have only 84.75%. As you can see, service performance and service availability are significantly different. And that's why it's critical to measure the service performance, because from a user perspective, something that is slow and something not available sometimes are considered the same. As Gartner say, discuss a lot with them, with SAP application, slow is a bit the new down. So that's why it's very important to have a view on all of that. The third one on the right is the network performance over time, meaning how often the network delivered good condition during the time we consider. And as we can see, on average, for all the locations, the pure availability was within our SLA, 98%. Performance were under our SLA, 84%. And you can see that it's obviously directly related to network performance that was only good 74% of the time. So below these gauges, we have on the left the sum up of the total downtime and warning per location, enabling you to instantly know where to focus to improve your end-user experience. Obviously, here, the robot user with bandwidth and with proxy have some end-user experience issues. On its right, you can see the count of issues for each action and each robot. So again, we see the same kind of result. It represents then the number of actions that were performed with a latency that is higher than the performance threshold we define, meaning you will certainly have tickets for all these actions. The graph below shows the time it takes to perform each action, robot per robot. So you have the detailed time it takes, detailed in milliseconds. And finally, at the bottom, we provide the pure statistics in milliseconds as well of the most important network KPIs to help you troubleshooting issues. Okay, so now that we are clear with what we are seeing here, Pavan, can you describe the results robot per robot?
Yeah. Yes, Jeff, sure. Let me go to the page. So we are going to discuss about the case 1. So that is bandwidth. So we can see here how important the bandwidth and SharePoint performance is. So let me go ahead and click on bandwidth. So as soon as you select the bandwidth, you see that availability for SharePoint is still about approximately 95%, but the user experience is horrible. Actions can be done with a latency only 33% of the time. So now AWS is behind us. Two things important to notice here. First, you have service quality at 33%, even if the usual network tests are up to 65% of the time. It means that half of the time, even with a normal network tools, you won't see how bad the service is. Also, if you look at the location per action, so let me go ahead and expand it. We can clearly see that the login and download are not really affected. But if you see that upload is constantly failing the performance test. So when we saw that, we checked internally, the answer is asymmetric bandwidth that was provided. So the bandwidth is actually good in download and but awful in upload. So if you have the same kind of issue, you should check with symmetry of your bandwidth in your regional locations. So let's go back to report and let's go to case 2. So as explained, we have a proxy scenario. So like the bandwidth, the proxy does really affect the end user performance on SharePoint. It gives us a warning or downtime 10 times higher than the normal conditions. So if you look at our performance SLA, we see that because of the proxy, we provide a normal service only at 93% of the time. We also see that mostly affects the login and the upload on SharePoint. Here, yeah, we can see like how much time it takes to log in and upload a file. So it is not something that you would easily detect with the traditional network tools. You need to be able to work the performance at action level to understand the impact of your route to the cloud. So as Microsoft recommend, we should stay away from proxies, especially if we have locations with a poor network connectivity. Let's go to the third use case, DNS. Now DNS is a bit different. In this case, we configured a DNS resolution to happen at the other side of the world. So we see that DNS resolution time is pretty bad. Okay, we can able to see here like how much time it takes on the bottom of the screen. The service is provided still pretty good. If you can able to see 99% is the service what we provided. So we meet our performance SLA, so which shows 99.38, and every action provide decent performance. If you can able to see, yeah, all actions like there is no much high latencies in each actions. So we can say like SharePoint is less affected by DNS resolution time than the bandwidth or the use of proxy. Yeah. Let's go to the next use case like distance to the cloud. So now for the last use case, we will compare the performance of our ideal robot that sits in Nice accessing a US tenant and with our robot that sits in a Nice accessing a European tenant. So results are predictable. We know that the shorter the distance is between your user and the cloud, the best performance you have. So Nice to US provide 99.3% service time. So let me go to ideal. Yes, see like 99.3% of service performance when Nice to Europe provides 99.59. Yeah. So also like Nice to US a warning of 6% and Nice to Europe only 5%. So you can see the difference, but it's not that big, at least between Europe and US. So it could be different with other care of world, especially if the network is not good in these locations. So distance definitely affect the performance, not by a lot, or really depend on the network between your users and the tenant they try to access. So that's all my use cases today.
Well, thank you. Thank you, Pavan. I hope it was good stuff for all of you. So we have seen in this webinar that SharePoint performance relies on plenty of factors. Of course, the way your pages are built, your bandwidth, your route to the cloud, the type of action your users are doing, of course, and sensitivity to latency. Not every location is the same, not every user is the same. So we've seen how you can use F12 and the SharePoint Diagnostic tool to troubleshoot page load issues. Then we've seen as well how you can use our robot to constantly monitor, to get these statistics in terms of end user experience, to understand the service you provide to your user. And finally, we showed you in real life the impact, the real impact of bandwidth, proxy, DNS resolution time, route to the cloud on your end user experience. So I guess now it's time for questions. Juliette, did we get any questions during this webinar?
Yes, thank you, Jeff, thank you, Pavan. We'll go ahead, with a few questions that came up in the chat window. Let's get started with the first one. You spoke about end user performance dashboard and explained that you got the statistics with robot users. Can you explain a bit more what they are and how they run?
Pavan, you want to go or I go? As you want.
Yeah, Jeff, you can go ahead. Yeah.
Okay. Well, robot users, they are Windows services. So they are it's a very small application. So Windows services that can run on every Windows 7 Plus or Windows Server 12 R2. So basically, usually our customer install that either on a VM or on a laptop or on a HDMI stick running a Windows OS. And and they perform all these actions. They are trying to use as much as they can the same exact protocol as the user, and they collect statistics in that SQL database.
Okay, thank you. I got a question about extraction of F12 statistics. Can we extract these statistics automatically and send that to the database?
Jeff, I take that question. Okay, let me show you. And there is an option to save and export the results into HTTP archive format, where we can able to see that information. But I can see I don't find any option to send the data to SQL database. So it's only export, and we can use HAR viewer to view that results.
Okay, sounds good. A question, can the SharePoint Diagnostic tool can also do login, upload, and download?
Jeff, I take that again. No. So actually SharePoint Online Diagnostic tool are designed to analyze classic publishing pages and pages on classic team sites. So it's not really perform a login, upload, and download scenarios.
Okay.
Thanks. You guys, you spoke a lot about SharePoint, not much about OneDrive. So we have a question: does F12 and the SharePoint Diagnostic tools work also for the OneDrive?
I haven't. I haven't seen anywhere like it's mentioned to use these above tools for OneDrive or business solution, but why not? Especially SP Online Diagnostic tool, what is designed to analyze classic sites on SP Online.
Okay. Also, I just want to add that the robot user work for OneDrive the same way than for SharePoint. So if you want to be able to measure this end user experience, etc., and get the same type of report that we have seen for SharePoint, so again, you can use this robot user on, in order to perform the exact same action: login, upload, download, collect the statistics, and then have a sense of your end user experience on OneDrive. Also, I have maybe something to say before finishing that webinar. We've seen a different use cases today. Again, proxy, bandwidth, etc. If you have other type of use case, if you think about other type of them, please let us know, especially when you fill the questionnaire at the end, because it's things that we love to test. So if you have some ideas, things that you would like us to test to see the impact on the user experience, please tell us, and we will do that. And of course, we will give you the results.
Brilliant. Thank you everyone. We also received some specific questions that we'll respond afterwards, after the webinar. Also, if you'd like to receive the slide of the presentation and the podcast, let us know in the survey. It's about to show up in your browser. Please take a moment to provide us with your feedback, and we appreciate you attending today. Thank you very much, everyone.
Thank you, Juliette. Thank you, Pavan. Thank you, everybody. Bye-bye.